Hello, everyone, and welcome to Bringing XPU to Production, our second panel for today. This is an interactive panel. We're aiming, like our renderer, to be interactive. That's a Steve joke. Thank you for that. So we have an amazing panel of devs and from the studio and the RenderMan side, and we're going to be talking about why XPU, how we got through development, and all kinds of other interesting topics. So please make sure you go in there, you chat, you ask questions, you answer our polls, and you participate, because that's really what this panel is all about. I'm going to get things kick-started with a little XPU video for those that are unfamiliar of what XPU is, and then we'll do a little introduction. So with that, I want to welcome Claudia, Florian on the studio side. I want to welcome Per, Mark, and Fran from our development side to join us in this panel. And again, I don't know if I introduced myself. I'm Leif. I'm part of the marketing team and one of the artists in our group. And I want to kick it off with Mark with a little intro of what he does in our team, and what's the first thing that got you into our industry?
Wow, that's a good question. So my name's Mark. My name's Mark, as Leif said. I'm the product manager for RenderMan. And what got me into the industry? Well, if I'm honest, I was of the age when The Little Mermaid actually came out. That it's what got me here. This is in the time before VHS really hit the scene, and so I hadn't watched all the set of Disney movies, and that just kind of hit me. I was like, oh my God, this is amazing. So I wanted to be an animator. That didn't actually work out, but I got into computer science, and then Toy Story came out in 1995, and I said, wait a second, I can combine these two things. So it was kind of the second golden age of Disney animation that got me here together with Toy Story. And I'll pass it, Claudia, you're closest to me, so I'll pass it off to you.
Okay, Mark. It's actually apt because it's a little similar to the story. Maybe we're aging ourselves together on this. But for me, it was two things. Beauty and the Beast. That was when the ballroom came out and it was computer generated. I remember seeing an article about how it was made. I was like, what? Math and science and art? What? My mind was like, I can do this. And then around that same time, Terminator 2 came out, which was the T-1000, the liquid metal, and I was like, oh my gosh, I need to get into VFX. The idea I could create things and people would just believe it was real. But I mean, the power, right? Like, and so that's what started me off, and I went into computer science from that point. I'll kick it to Florian.
Hi. Hey, I'm Florian. I'm in tools production at Pixar Studios, supporting the artists there. What got me into computer graphics is actual games origin. I've seen Toy Story. It's amazing. I've seen every Pixar movie. Always loved it, but it seemed unobtainable. I couldn't get there. How could I get there? So I focused more on the game angle, and eventually life took a turn after college, and it's like, oh, I'm working at Pixar now. Well, that's okay. So I've very much enjoyed my time at Pixar so far. I'm tossing it over to Pierre.
Yeah, hi. My name is Pierre Christensen. I'm a principal scientist in the RenderMan team. And for me, the thing that got me hooked was the movie Tron. And I think if I were to watch that movie now, I probably wouldn't like it very much. But at the time, I thought it was the most fantastic thing in the world. So that's what got me hooked. All right, next up is Fran.
Yes, so hi everyone. Really nice to be here with all of you. My name is Fran Gonzalez. I'm a senior software engineer at the RenderMan team, and I'm mostly working in XPU. So you can blame me if you have any issues, or at least partially you can blame me. But the thing that got me into this industry, I have to be honest, my whole thing is quite similar to Florian. It was all about video games. I was a huge fan of Nintendo video games since I was a teenager, and I always thought, oh, how could we, I mean, I could imagine a day that Pixar movies could be rendered in real time, and it would be awesome. So yeah, so working here at Pixar and with XPU, it has been like a dream come true. And passing it out to Oliver.
Mute helps. I'm Oliver. I'm the VP of the RenderMan group. I think I can connect closest to Mark. I think I was always interested in technology and character animation, especially if you see the movies from the early days, if it was Tron or Toy Story. And I thought myself, like, I can do it, and then failed miserably on character animation. So I decided technology is the right track to go, which I'm doing for many, many years now. And I'm happy that when I joined Pixar 2 years ago, to be part of this awesome RenderMan team and push the boundaries of RenderMan.
That's awesome. So many, weird stories of like serendipitously getting to Pixar, right, from different backgrounds. I mean, we even have people that studied aerospace engineer on our team, like different people that come from different backgrounds. Like, I started only like watching, Akira, Ghost in the Shell, only like old school anime and stuff as a teenager, and it was Final Fantasy VII on the PS1 that got me into like 3D. I'm like, what? I want to get there and do that, So that was a big thing for me. So I'm glad you guys shared everything as awesome. I'm sure you guys have your own ideas there in the chat. So please go in there and answer our poll and tell us. So I want to get the panel started with a super simple question, right? Why XPU? Why rewrite the render? And I think I have. I think I know a lot of reason why, but you guys bring super different perspectives on what it is to reinvent the rendering technology at Pixar, and what kind of inflection points have to happen. Which is a super interesting topic. I think Mark might be able to give us a little bit of history here on the transition from RIS to XPU.
Sure. So, like you said, I think there's a variety of perspectives on why. Why would we do something completely new instead of just going and augmenting or evolving kind of RIS more gradually to XPU? And I think there's lots of different answers, so I'm just going to kind of give you my truth, or the one that resonates most with me. And that was, so we started working on XPU. Really, the first prototype was in 2016, I think. But I know the team had investigated and had thought about GPU rendering even before that time. Right? I came onto the scene in 2015, so I can only give you that perspective. But it was really quite clear of what was happening from an underlying technology perspective. CPUs were getting wider. That is, the number of cores that was in those CPUs was increasing significantly. You can look at the latest hardware from both AMD and Intel, and you see this trend towards wide computing. And then the GPUs, were also evolving really quite quickly. And, it's sort of similar in that it's a wide compute architecture, right? Computing many, 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 many things simultaneously. And, that was kind of fundamentally different from old computers where you just would have, it was kind of far more linear, with a much smaller number of cores. And so we said, okay, this is an opportunity to rethink rendering and what it means to do it kind of wide. And, we did some initial experimentation, and those experiments were promising enough. We said, okay, we need to take a deep breath. For those of you that had attended the previous session, you heard Steve May said, oh, I've been using RenderMan since 1991. RenderMan's unique in its longevity. And like, name a piece of software, other than like Unix or Windows, that has that longevity to it. And we said, look, if we want to be around for 10, 15, 20 more years, get to an inflection point, as you were talking about, like that. We were at an inflection point. Technology was at an inflection point. So we decided to take a deep breath and go forward. It's taking us some time. There's no doubt. XPU is not done yet. We're not going to claim it can render the breadth of pictures that RIS can render right now. But it's paying dividends. Like, XPU's performance, even in CPU mode only, is above RIS, by a significant margin, let alone the acceleration that the GPU adds to it. So it's all a very long way of saying that the technology was changing, and we had to be brave. And there's been pain. I'm not going to claim it's been smooth. It's been hard, but I think we made the right choice.
Anything worth doing has got to be a little bit hard, right? A little bit hard.
I think that's a really good.
Yeah, I think. Yeah.
And really also RenderMan with the RIS generation, switched to path tracing. There's now a couple of years of path tracing inside of RenderMan, and we've learned so much from how it behaves, what we expect of a modern path tracer, and that building it on the same infrastructure that we had in the past will just get us only so far. And to go further than all the way we want to go requires, to some extent, a fresh foundation, and that's what this is all about.
Yeah. Plus one for I totally agree.
Yeah, and like Mark said, we were building off a lot of knowledge from the people that were already working on GPU rendering, like Florian at the studio. There was an internal solution already that got us really close, but not quite as close as XPU to Final Pixel. And matching some of that kind of pixel parity was super crucial to bridging that gap, right, of RIS and XPU, of like getting that 99.9% pixel parity, right? I think, Florian, how can you kind of like visualize that transition from what we used to have at the studio with Flow and RTP to XPU? How long was that transition, and what were the differences in those two systems?
Yeah, good point. So for those on the outside that might not be aware of our in-house tooling, we have an in-house shading tool called Flow. There's been presentations about it outside, which is a node graph-based shading tool, making procedural shading networks based on our own OSL shaders. And our final renders in the studio are all rendered with RenderMan RIS. But to accelerate our users' workflow, is that we built a preview render, real-time RTP, a real-time previewer. That is a path tracer, GPU accelerated, that is supposed to give you a preview of your shading as you're going to see it as a final version in RenderMan RIS. But RenderMan RIS is the reference. This is what we're going to use for our final frames. And what was good about this project is we were able to get to some levels of interactivity and feedback and kind of work cycle for the artist that was super interactive and super nice. But the difference that it is not actually the final render. This is a different render that we've written. We have to maintain the preview render with the final version. If the final version changes, the preview has to change. And that's a lot of work. And it's extremely hard to get it right. There's some parts where we never got it right. Like subsurface scattering is one of them. And so we want that fast interactivity, the preview capability, but we also want to have accuracy and predictiveness. So that when a user makes a choice in the interactive shading environment, they are sure it's going to come out right in the final renderer, and not having to worry that, oh, I've made this tweak here, but let me check with the final render and the slow render again. It's like, no. You want the fast render video, final render at the same time. And that's what XPU is the render that will be the final render and will be the interactive render at the same time. And
that's a really good point, because right now we're like at that transition, right, of coming from something that was close, like RTP, and really interactive, and something that's going to be more predictive of final pixel. But we're not quite there yet for final output, you know. So we're really kind of focusing in this look development focus at the studio, and people don't know out there, but Flow is like, it's like a substance, right? It's like a fully procedural builder, and some networks can have hundreds of nodes of OSL and noises and all kinds of crazy data. And XPU is kind of built on this really heavy production foundation, you know. So I'd like to ask Pierre and Fran, what were the challenges of, like, I know you guys worked on the OSL stuff directly, you know, and all that transition. What were the biggest challenges of, like, getting RIS to switch completely over to OSL, changing, you know, like adopting all this code and making it studio wide?
I think that I couldn't say just one thing. I mean, the whole journey has been like a huge challenge for all of us, for all the team. But before going into more deep into this question, I would like to add a little bit of sauce to the previous question about why we built XPU. So I think that for me, I still remember when I joined the team 3 years ago, and it was just the moment we were releasing RenderMan 22 with the interactive renderer. It was quite a lot of work that the team did just to make all the architectural changes within the existing architecture of RenderMan RIS to make it interactive. So you can imagine how big of a change it would be, like into the current render, how many changes we would have done to even make it efficient and be able to handle different type of devices, GPUs at the same time efficiently. So I think it was no-brainer for us just to start from the scratch with a new architecture. And as Mark said, even the CPU variant of XPU is way faster than RenderMan RIS, so that's great. So for me, it's like it was no-brainer to go into that direction. And challenges, wow. I mean, we have been finding challenges like every day. For instance, programming CPU and GPU at the same time. You have to take care that the way you are focusing an algorithm, or how you are trying to implement one specific feature that was working super great in RenderMan RIS is going to work even better in the GPU, but also on the CPU as well, which are different type of architectures, and sometimes it's quite difficult to have something that is performing pretty well on both type of devices. So yes, it's like every day we have challenges. It's not like we don't have good challenges. So it's like every day is a complete challenge, which is great. I mean, probably that's why we love our work and we enjoy doing what we do.
I think for me, the challenges are making sure that XPU is really matching RIS, because there are so many corner cases, the Pixar studio scenes, you know, the patterns, the BXDFs, the models, the geometry. It's also very, very complex, and we have to make sure that when you switch from XPU to RIS or the other way around, they match 100%. And it's a long way. I mean, it's been a long way, and we still have quite some ways to go there, just to make sure that every single combination of values and options and settings all match. So that's been the challenge. I would say it's also been very rewarding in the sense that we can really see the work pay off in the speed up we see. I mean, oftentimes I'd say a typical case just running on CPUs is 4 times faster with XPU than with RIS, and that's a lot of variation, but that 4x is what I've seen as an average over many different scenes. And then when you add the GPU, you know, then maybe it's 15 times faster or something like that in average. And you can then have both CPU and GPU, and it's even faster. So yes, lots of challenges, but also lots of reward along the way.
You know, and piggybacking on all this amazing info that you guys are giving us, you know, I think this is a good one for Oliver. You know, what we've been focusing the talk on the studio relationship and how the studio itself, you know, is kind of developing all this amazing magic. You know, how can the rest of the world kind of benefit from all this? You know, where we have a workflow at the studio with Flow and how that pipes into USD and everything else in our pipes. You know, how can people at home or people in other large studios, you know, use RenderMan for, you know, their stuff and XPU in particular?
Well, I think there's a variety of ways how they can participate. I think in general, our goal is to obviously make the best movies on the planet. But production pushes technology so far that obviously the RenderMan team benefits largely from that expertise that we have at the studio from a creative side. I mean, in a traditional software business, I would say it's the job of a product manager to go out to an artist, to customers, and ask for their feedback. And we have the luxury of having these artists on site, so we can ask them every single day, 8 hours a day, and get their feedback. And I think this makes RenderMan very special because it is completely artist-driven. And RenderMan, again, is in a very unique situation because we're not just serving Pixar. We get this input from a bigger ecosystem where it's ILM or MPC or customers out there also working on a variety of shows, not just feature animation, but visual effects shots, which is a very different data set that is usually computed. And combining this expertise on one single platform, in this case RenderMan, makes it very special. And I think for people out there, obviously having access to RenderMan is a first good step. So it doesn't replace like all the OSL shaders that Florian mentioned that we have in-house, but you can write your own. I mean, every pipeline is different, every need's different, and for us, the goal is also to create a very open architecture that people can write their own shaders using OSL, leveraging open source technologies such as USD to pipe into the rendering pipeline, and adjust it to your needs. So I think we're far away. We're actually the opposite of forcing people down one pipeline and say, okay, that's the way it needs to work. Deal with it or look for something else. I think we exactly the opposite, where we try to make it as open as possible, but also engage closely with our industry vendors, if it's Side Effects or Foundry, Autodesk, the Blender community now, to really nail every single feature in RenderMan and make it as good as it can be. And again, we're also here to listen. I mean, there's a ton of great developers and people out there with a ton of great ideas, and usually this is what SIGGRAPH is for, to meet in person and geek out. So it's a little bit more challenging these days. But we also love the open discussion with the community to see how we can make the renderer even better. And as you can also see in our dot releases, you get a ton of new stuff. So it's not that a 24.1 only has fixes in there. There's also a ton of new stuff that's just coming back from Open or from our industry vendors now with the latest update to our Substance Painter plugins, that we're able to push that out really quickly to the community.
I mean, we just released 24.1, right, a couple of days ago, and like you were mentioning, like there's updates for the Substance Painter plugin. It's unofficial, but you know, it's a developer from our team that's doing these things. You can actually export llama networks and do all these things, and these things have, you know, happened because of the changes that we got into our dot releases and all kinds of innovation. So, you know, expect to see that as we get through this year and through, you know, 25 going forward. You know, so you know, I think that's a great way to piggyback to like receiving feedback, right? Of getting industry feedback, and our internal version of that is, you know, Florian and Claudia. You know, I think, you know, you've been doing a lot of work, Claudia, right, within the studio of getting actual XPU into like new and innovative places, right? Like and actually doing key lighting or other kind of cool things. Can you tell us a little bit about how the studio kind of, you know, where it's at now with XPU and where it's kind of might be going in the near future?
Yeah, I think, you know, when Mark was talking about wide computing, I wrote that down because I think the speed of XPU, the future, and what we're experimenting right now in production on some feature films that are happening like way in the future is like Flow is kind of like a shading in-house tool that we use, but we're working with now this new way of RenderMan in our proprietary software in Presto, and that's all our shot departments now seeing kind of a real-time render of our scene, and it is in some ways wide computing of the production pipeline, right? We have all these departments, lighting, layout, working together, shading working together, and it's crazy, it's bonkers, it's chaos, but in a good way. I think when we were kind of sharing some of our really just raw images that we're getting with this, I think maybe it was Florian, I don't remember, asked the question like, that thing that's glowing, is that a shading or a lighting problem? And I was like, no, that's a production, that's a movie problem, that's a film problem. So it's like the walls are breaking down in how we're working together, and it's bonkers. It's awesome.
That's awesome.
Can't be stressed enough how useful early feedback is. The earlier you know how the final frame will come together, the better choices you can make up front. And the better choices you can make up front, the smoother the right wheel on the end. The long feedback cycles from something being found in lighting as an issue that could have been solved in layout, that's super expensive in our production to fix and address. So the sooner we get feedback from the visualization for every artist along the line, how the final product will look like, the better choices they can make, instead of having to wait from submitting it to render queue, getting a nightly render back, seeing a review, getting a note, and then addressing it back at a desk, as if they could just see it at their desk. Like that's the goal right. what we're going for.
Yeah, Florian, you're exactly right. Like, Per mentioned, like, how shading networks can get really complex and crazy, like what we do in production. It is super complex, but there's something where if you get in early together, it actually simplifies, I think, what we're trying to build, because you're not fix on top of fix on top of fix. You're truly very strategically, very targeted to the look dev and the creative, I think, of what we're trying to build.
Yeah, because XPU has limitations, of course, right? We're in this period where we're developing, color in the back and like light temperature and things that might be considered basic for RIS, but as it stands, it's just like you're saying, it brings so much to the table in simple things like, I don't know, contact shadows or making sure that geometry is not breaking in the right way, or that, so there's just so much there you can see in context, P-text, all your stuff, all your OSL shading, all in context of the shot, which is amazing, You guys had some developments also on the flow side, right? To actually be able to see like shots in context while you're actually shading and stuff like that. Is that some kind of cool stuff that you're looking to implement soon, or just some crazy test?
Well, it's hopefully it will be the future. Like we start with a test. It's like, is this feasible? And you saw a little snippet in the trailer that Live showed at the beginning. Shots from material from Luca. There was actually a question in the chat, which is like, how much was XP used on Luca? It was not ready when Luca was in production. But of course, we use all the heavy assets that completely shaded with lots of 4K textures and lots of complicated shading networks to test XPU. And so we took a part of an actual shot, a USD-based shot cache with full animation, take a frame, that's cool, and take all the characters out and load them into XPU. And we can tumble around that view, we can make shading changes. And that's the kind of experience that we're after. Like an interactive experience where people can get fast feedback on their artistic choices. But usually, and this might not be obvious to everyone, people, artists, shading artists, look at artists at Pixar, shade one thing at a time. They shade the shirt, they shade the pants, they shade the skin, they shade the hair, they shade the hat. But if you're only doing one thing at a time, then you need to do a final render to see together, react to those things that you see and go back. The goal for us is to bring more things together in context. Context is the big keyword here, is you see the whole character with all the parts together, they can shade them together. You bring in multiple characters together to see them as an ensemble, shade the whole line up, or put the character in an environment and see how these things play off each other to make sure that the art style, and with our very stylized art forms, this requires a lot of back and forth and seeing things in context. So for us, the goal is to render more together in one place, so that artists can say, I'm going to work in that shot, load everything up, and then shade the parts that have been assigned to work on. That is the goal. That's where in-house tooling is going towards. But actually, that's part of the story that goes with the render is our preview render was built out to essentially handle one asset at a time. But at some point, it falls off a cliff. It runs out of memory. It's not as efficient as RenderMan and XPU is. And so to actually grow to this massive context that we're striving to get to, we need a render that is geared to be the final render. That's exactly what XPU is for us.
That's right.
So that's the reason why we're pushing in this direction.
That's so amazing because that touches on like so many other things, like collaboration, with NVIDIA. That touches on like getting all this native code on the GPU, on memory, on so many hurdles that were so massive to jump, and that are taking us in kind of new places that will allow us to do new things. I think there's a great question from Mark right here. How are these kind of new questions improving memory handling or improving these kind of black box calculations that are happening in our relationship with NVIDIA and our CUDA and our ray tracer code?
Yeah, that's a good question. There's a lot of big questions like that to ask for a GPU renderer. I like to think about scene scale and the complexity of renders and how that's changing over time. If you go back to the earliest days of RenderMan, it was architected so that you could fit, your scene could be much larger than your memory, right? And that's what the Reyes algorithm allows you to do. But with path tracing, you need the geometry because rays are going in every which direction. And so you have to start to be really careful about how much space you're taking up for geometry and how much space you're taking up for texturing. So that was kind of one of the big questions that we were answering early on was, can we compress the geometry to a significant extent such that we're not kind of losing fidelity of that geometry, but able to fit more into the GPUs. And then we were looking at memory trajectory of how much our memory increasing on graphics cards. Because it's hard, right? Like, let's be honest. If you have a 6 GB graphics card, you're not going to be rendering a Pixar shot. It's just not going to happen. Like you need significantly more than that. But the cards that NVIDIA's delivering now, it's like, ooh, okay, that's really interesting. Now we can't lose all discipline, and we still have to be disciplined in how we get things onto the GPU and the types of geometry we're compressing. But all of a sudden now, it's like there's some really, really interesting things happening in the space. And then furthermore, if for some reason you have some shot that's just, there's no way it's going to fit into a graphics card, okay, fine. That's what XPU CPU is for. That's the other reason that we're doing XPU and not just a CPU renderer and not just a GPU renderer. It's to enable as much processing as can happen on your device, right? That could be locally with the CPU and GPU, but maybe your render farm only has CPUs, or you're going out to a spot instance on a cloud provider, right, where it doesn't have a GPU, but it has a CPU. So,
right.
We've architected to have this fluidity back and forth, but still paying very close attention to how we're optimizing as much as we possibly can that space on the.
And there's so much to consider, right? From a resource perspective, right? Why would you have kind of a resource agnostic render? You start seeing a bunch of benefits, right? Something as simple as, for a large farm, energy use, right? What is more efficient to render with one or the other? I can make that choice, cost, chip shortages are driving cost up for certain things. I can choose to make this or this my processing power, and all that fluctuates through time. And having a render that can adapt to all those kind of market changes is super crucial, right? And
yeah,
even building tools, artist tools, we in our DCC are building the new stats, to make you understand where these resources are going, and all these things, and make those more informed kind of choices,
Yeah, no, exactly. Just to add on what you're saying, One of the things that I believe makes RenderMan really quite compelling as a renderer is we try and not make assumptions about what artists want to do, the types of stories they want to tell, the pictures they want to create. But the same thing goes for the technology stack. Like, we don't want to make presumptions on what machine type you have, or what your farm looks like, or are you rendering to the cloud or completely on premise? And if you are rendering to the cloud, then what? And the same for compute architectures. It's like, well, Intel and AMD have a bunch of smart people, and NVIDIA and the other graphics card vendors, but NVIDIA for now, have a bunch of smart people. Just take advantage of all the smart people. Like do everything at once, rather than trying to presume and to make choices that honestly aren't up to us. It should be up to the community and studios and users how they want to use XPU and how they want to render.
Right. I think we could, this is a really good topic to transition to this great question, that we have from our audience. We can get started with Oliver, I think, because you guys are going to have a different perspective on where this is at, depending on how much viewpoint you're looking at from. How far are we truly from being able to use XPU on the farm to kind of render those final pixels in the future?
I would say it depends on how fast our developers can develop, but well, I think we're a little bit out. I mean, our main focus at this point is looked at for 24, and I mean, we make our best effort to get to the point where we can deliver final frames as soon as possible. So realistically, it's not happening within the next year, that's for sure. But we're definitely targeting something more in the RenderMan, probably 26, 27 time frame, somewhere there. But it also depends what kinds of new challenges are coming up during that time. As Fran mentioned, I think there's daily challenges, and we try to be very efficient on the hardware side, how we compute the pixels and what we can achieve. And it also depends on how fast NVIDIA and AMD and Intel are delivering new chips and GPUs, and how fast they're going to go, because it influences our roadmap also quite a bit. So yeah, short answer, not in the super short term, but we make our best effort to make it mid-term and not long-term.
So this is a good question, I think. Given that many render farms don't have GPUs yet as their core, rendering racehorse, what benefits does XPU have for GPU-less farms, right? For CPU-only farms?
Well, it's way faster, right? Even the CPU system has been completely rewritten for modern architectures. It is like 4x faster for many renders that we are seeing. So even just the rewrite of having a fresh architecture, take everything we've learned for the last couple of years of path tracing and putting into a new system, it shows out of the get-go. So that's a huge speed bump just by switching to the CPU version. And I think, right, what Oliver mentioned is there's ways to go until we're at feature parity with RIS, which might never happen. Like, RIS has acquired many specific features for many tasks, but we're getting closer and closer to have all the features that you might need for your final renders. If you need everything that RIS can do, well, maybe you need to render with RIS for a while. But XPU is going to creep up and make sure it can do all the things that it has to do for final rendering, and by being faster along the way, all the time.
And we're talking about being faster currently, right? With this like really, kind of brute force mentality, right? For like look development. XPU has ways to go to increase on speed even further, with all kinds of new optimizations and things that we'll learn. So it's super exciting to see where it's going. In keeping on the GPU talk, I have a question here. Does it matter which GPU architecture you use? I know that we're CUDA only and NVIDIA only for now. Can we talk a little bit about the plans for the future there, minimum requirements and that kind of thing?
Yeah, I can take some of that. At the end of the day, XPU is what we call a multi-device architecture. So kudos to the engineering team for kind of the numericism, that's even a word, of the architecture, where XPU is fundamentally designed such that any architecture can be used and contribute to creating a renderer. But then there's reality, right? And the reality is right now we support kind of Intel-based CPUs or AMD CPUs and NVIDIA GPUs. So if we expand to others in the future, we'll see. But we can definitely say that we're architected to be flexible. I don't know, Pierre or Fran, do you want to add?
Yeah, I think that from my point of view, XPU is just going to get better and better. I mean, we are already working on improving some parts of XPU that we knew that could get even to the next level in performance. So yes, because as Oliver said, we are in that great position in which we can collaborate with artists at the studio and with the tools team. We can collaborate with other vendors like NVIDIA to make XPU the best it can be. And for instance, we are already exploring the usage of optics in the future, how it can fit within the XPU. Even XPU is just CUDA-based right now. So yeah, so it is going to get better, and it's amazing to hear from artists at the studio that the experience with XP is already somehow transforming the way they are working. Because if it's already transforming it, it's going to be even more transformative in the future. So that's awesome.
So I have a more general question. I think Oliver can start this one off, and I think everyone will have their own idea here. Why does Pixar use its own development software teams and custom software instead of using commercial software?
Yeah, it's a good and tricky one at the same time. I mean, we use commercial software. I mean, we're using Katana, we're using Houdini, we're using Maya. But our in-house teams are really there for customizing some of the tools, but we have tools like Flow and Presto where we actually put the focus on the tools where we're best at. And I mean, Florian and Claudia can speak more to that. But we're having so many productions going on at the same time that oftentimes there is like customization that needs to happen based on the show. And we can't wait necessarily until commercial vendors keep up. So this is where we see it more like we extending the toolkit that we have. It's a little bit different with Presto and Flow, but it's definitely true for Houdini and Maya, where we just extend and see how we can even make the data flow between, let's say, Houdini and Presto work, and how we can represent data in a real-time fashion to judge the pixels as soon as we can. So there's always a need for in-house development versus commercial tools. And actually, the truth at Pixar is we use both. We're not entirely in-house solution-driven. It's a mix of both.
And let me just add that. So as far as the render, I mean, so RenderMan, since it's a Pixar developed program, if there's a bug, we can fix it right away. If there's a new feature, we can try to add it as quickly as possible in time for the movie production that needs it. So that close, very tight loop is not really feasible with an external vendor of rendering software. So that was the reason RenderMan was developed to begin with, and that's still the case.
Yeah, I can only second that. Being responsive to the needs of production, being able to do custom fixes, custom tooling, as we learn during production. Like we often learn about a problem that needs to be solved late in production, and now that problem needs to be solved, and someone has to write custom code either in the render or in the tooling in the pipeline to make that happen. That's how we do it. And as Oliver mentioned, we use lots of external software, from Mari to Katana to Maya, all the tools, but we always heavily extend them, meaning we write plugins for them, additional scripts and whatnot. So our tooling, even if it's off the shelf, is never off the shelf. It has been heavily customized. And sometimes we go the extra mile, so to speak, by actually writing a complete software package ourselves. And like in the example of our in-house looked at tool Flow, that was built on Presto parts. So we're using the essentially animation application framework, the whole undo system, the layering system, the native USD support, and we turned it into a shading tool. We plopped in a nice node graph for our artists. We connected it to an interactive render, and now we have a shading tool. It's a little bit more complicated than that, but that's the essence of it. And that allows us to customize it and address the needs of our artists. And we have essentially a really USD native editor. So in our world, shading, geometry, everything is USD, and we have the most native USD editor that we could find in the market. And we restarted it. There was nothing else out there. There was no Solaris, no anything. So Solaris has come a long way. So that is an exciting product as well. And people use Solaris as well as Studio, of course.
Yeah, I mean, and Solaris is also like an amazing result of collaboration, right? Just like NVIDIA and XPU, you know, it's a collaboration between the USD teams at Pixar, you know, and Side Effects. So there's always so much of that collaboration happening, you know, at Pixar. It keeps us lively, I think, you know, and that talks about development, you know, custom of every movie has its own kind of magic, and you need something special sometimes that cannot be you know, answered by commercial software, because, you know, they answer a more kind of wider range of things. You know, we have very specific edge cases, like Florian said before, where, you know, where things might kind of fall apart. So having that complete control is super crucial. You know, I want to open it to one last question. What are the things, Mark, that you see in 24 that we still have to develop for XPU? Any kind of exciting new features that people can expect during this development cycle, and any new features that you'd like to see in 25 personally, to kind of you know, reach some goals from the studio perspective and the outside world.
Yeah, so kind of two-parter there. So in 24, you know, we're continuing down the bug fix path. You know, some of the things that Pierre mentioned about getting kind of more and more predictivity of XPU compared to RISC, like that will be a continued focus. Other performance improvements as well, like, you know, we've been working on kind of geometry handling and time to first pixel. So my hope is that will get better, you know, in 24.2, 24.3. Fran is working on some new texture cache functionality. Unclear if that'll be in 24 or 25, but you know, that's coming. Bringing Llama and kind of finishing the look dev features of XPU is going to be an important one. And again, you might see that in 25. You know, we still have to figure out the versioning, and then continuing down the use case that Claudia describes. Like, I want to hold her statements kind of up on a pedestal about how when you enable interactive rendering earlier in their production, it allows artists to iterate more quickly, and allows them to bring, you know, kind of more interesting images to a review session, and it sparks just amazing conversation on the production. And so working on features that can help enable that kind of collaboration on the production is going to be important for us going forward. And then eventually getting to the point where, you know, we can start to render final images, right? It's a journey. It's like a, you know, and there's several kind of train stops on the way, and you know, so we're just going through them. And this next one, beyond look dev, would be the types of things that Claudia and the team with future productions.
Well, we're out of time. We need to give our next panel some time to get prepped up and going. Don't miss out on our next panel, which is also GPU and XPU based. And they'll be talking about Solaris, USD, and XPU and Houdini. So stick around for that. I just want to thank you guys for coming on, talking about all the amazing things that we're doing at the studio, at our dev team to kind of make magic at Pixar. So I'll sign off, and thank you so much, everyone, for coming in and asking great questions and chatting with us. So until next time, and stay tuned. Bye, guys.
Bye.